Question 9, we have got a student investigating how the pressure of gas varies with volume. Okay, during the experiment we're told that the mass and the temperature of the gas were constant, and we've got a picture here of the equipment used by the students. So we've got a fixed amount of gas in the measuring cylinder connected to a pressure gauge, so we can read off the volume just by looking at the syringe scale, and the pressure gauge would give us measurements of what the pressure is. Okay, so first of all, the resolution of the syringe. So remember, resolution is the smallest difference that the instrument can read. Okay, so looking at our syringe, it should be quite clear that the smallest change that we could measure is 1 centimeter cubed. Okay, so the student compressed the gas in the syringe, read off the pressure, recorded the volume, and these are the results that they obtained. Okay, now the next part of the question wants us to make a conclusion from looking at that graph. Okay, so let's go back and have another look at that graph. So this shape of graph should be recognizable to you. It's clearly not a proportional graph. What we're looking at here is an inversely proportional graph. Okay, what does that mean? It means as the volume gets bigger, the pressure gets smaller, and as the volume gets smaller, the pressure gets bigger. Okay, if you revise this carefully, you should recognize that you've learnt this relationship, and what is actually going on is that those two things multiplied together are a constant. So the pressure multiplied by the volume is constant. So if one of those things gets bigger by a certain amount, the other must get smaller by the same amount, so they still multiply together to give the same thing. Okay, so what we need to write here is that the pressure is inversely proportional to the volume. Okay, now there are 3 marks for this question, so just saying that isn't going to get us all 3 marks. Okay, the clue that we've got to do more is that little phrase there, use data from figure 11 in your answer. So what this means is we actually have to pick some data from the graph to prove that point. So let's go back to that graph one more time and do that. Okay, so what we're looking to do is to show the inverse proportionality. In other words, to show that the pressure times the volume is a constant. Okay, now we can do that just by picking 2 points if we pick them quite carefully. So first of all, let's pick this point here where we've got a pressure of 200 and we've got a volume of 8. So 200 times 8 gives us 1,600. Okay, so that's 1 point. Okay, now this is another point that's quite nice to look at as well. Okay, we've got pressure there of 160 and we've got a volume there of 10. So if we times those two things together again, we get 1,600 again. So we're getting the same answer, which is confirming that those two things multiply together to make a constant, which is confirming that the relationship is an inverse proportional relationship. Okay, so if we added what we've just done there into our answer, that'll get us the full marks for that part of the question. And the final part of question 9 is to explain why the pressure in a gas increases as the gas is compressed. Okay, so compressing the gas simply means that we are reducing the volume. Okay, Okay, because we've reduced the volume, that means that the particles of the gas are going to collide with the walls of the container more often, more frequently. Okay, so each time there's a collision, that causes a small amount of force. Okay, so overall there is a greater force because each collision causes a small amount of force. There are more frequent collisions, so there is greater force and therefore greater pressure. Okay, so hopefully that is a fairly good explanation of why.